I think that was an AI-generated image. OK. All right, so I'm going to talk about management of risk in LLMs. I'm going to divide the talk into 3 parts. The first is the why is risk management so important as use cases with LLM go into production. How is risk created in an LLM pipeline? And then I added one more to that, what. What can you do as remedial steps to address these challenges? And I'm going to try and do that in 7 minutes. OK. And the clicker. Oh, that one. OK. All right. AI is at the hype of its life cycle. This chart from Gartner very clearly explains that. What is as important is regulators are starting to look at this very closely. Recently, in March of this year, European regulators decided to shut down OpenAI in Europe because of copyright data. We are also seeing US regulators looking at this very carefully, where AI affects the livelihood of individuals, right? In addition, the European regulators are looking at this from 2 main aspects. When GAI gives a decision, what is the reasoning behind it? That's actually becoming very critical. And secondly, they want a human overlay on top of this to make sure that an GAI-driven outcome is moderated by a human before it goes to the consumer. So there's obviously great regulatory scrutiny. Let's look at the risk pipeline from a perspective of where is the risk created, or how is the risk generated in this? When we start here, when you define your use cases, it's important. Obviously, the copyright piece is copyright PI is pretty critical. But a subtle element is also selecting the right foundation approach and architecture. So for example, if you had a classification use case, you might just say, listen, an encoder-only model should be sufficient to handle this. If you didn't understand that, catch me in the hallway, I'll explain that. Now, when you define the performance metrics for your LLM, it's also important to figure out what your validation data sets are. And especially on the edges, the stress data sets are very critical. When you build your model, somewhere early in the session today, people talked about the label data set and how important it is for fine-tuning. If you have mislabeling, that can result in serious risk hallucinations of the model downstream, and your recommendations could go off course. So getting your label data as accurate as possible is very critical. Fourth, as you put your model into production, it's also very critical that you handle for security policy risk. Take an example. If I had a wealth management app and I put it into production, it's giving advice on wealth, and if through prompt injection somebody started to extract wealth PII information, that's a serious problem, right? So prior to putting it into production, you have to run system-level checks, and I'll speak a little bit about this later. Now that we understand how risk is generated into the pipeline, let's look at individual blocks in there. So you've got pre-training data and foundation models. The first thing that you want to check is your foundation model leaking risk into your use case? Let's take an example. In a legal environment, the word shall and consideration is very critical, and it has impact from a contractual perspective. If you have a general purpose LLM and these words are used more casually, you could create hallucination or wrong answers, right? It's also one of the things we've been doing quite a bit of research, and a shout out to a couple of members of my team who are here. C4 dataset from Google is one of the cleanest dataset to use for pre-training. So that's the tip I'm passing on. The other piece is when you look at Helm or Superglue, these are great standardized tests for benchmarking, like on toxicity or polarity, etc. But it's also important for you to have similar benchmark tests for your use cases, because those will not be standardized, right? So be watchful for that and build those also. When you think about the models, it's important. You can build your own model if you've got very specialized data. But we propose that build models with small to mid-sized foundation models with 30 billion parameters or less. Better still, use something like FLAN T5. T5 is from Google. FLAN T5 is a pre-tuned model on top of the foundation model, and it has like 400 data sets and 2,000 tasks that it does work on. And it's easily controllable and manageable to build your use cases. So small is better. When you look at the label data set and from a fine-tuning perspective, you can have explicit bias is obvious, but you can also have implicit bias. So in a customer support environment, if gender or location goes into somehow into the variations and recommendations, that can attract serious regulatory scrutiny. When you are putting your models from a fine-tuning perspective, when you're tuning your models, if you're building your own models, remember your distribution curve is going to be very narrow. You've got to take care of your edges, the 2 sigma. If you're fully fine-tuning your model, be careful about catastrophic forgetting. That's a mouthful. We propose parameter-efficient fine-tuning, which is cost-efficient and can give you 75 to 85% results of a fully tuned model. And we have tried that with a bunch of examples. We've got pretty good results. Moving on. When you deploy your models to production, scale through this animation here. When you put your models to production, you will have scenarios you will have to provide in real time context information through external databases. It's important to make sure your data sets are highly versioned and citations are available passed in the LLM recommendation so people know where it's coming from. The query encoder, which is really the engine that decides what chunk of information I'm going to pull out of my RAGs, that query engine has to be highly optimized. If you don't, you run the risk of essentially having a suboptimal entire engine, and even if your model is great, you could end up with bad results. Lastly, 3 key takeaways. First one, design your LLM pipeline carefully. Focus on what's your overall budget, your compute capacity, the type of data that you have, and what are your constraints around the model. Second, test the heck out of your use cases for edge cases and stress. Cannot be said more, whether it's for the foundation model or the fine-tuned model. Lastly, continuously monitor these in production, because when you put it in production, you're going to have some example scenarios that you didn't think about before. That's it. Thank you.